Welcome to Ask and Learn.
In this problem, we are going to calculate the angle theta. In order to calculate this angle, let's apply the law of conservation of energy as Ti plus Vi is equals to Tf plus Vf. This can be written as 0 plus W into L by 2 is equals to Tf, which is equals to 1 divided by 2 Ia omega square plus W into L by 2 cosine of theta. We call it equation number 1. Now let's calculate these terms one by one. So first we calculate this Ia, moment of inertia, which can be written as 1 divided by 12 ml square plus m into L by 2 square. Now by inserting values into this equation, we can write this Ia as Ia is equals to 1 divided by 12 into m, which is equals to 30 lb divided by 32.2 feet per second square into L, which is equals to 10 feet whole square plus 30 divided by 32.2, and here is LB, and we can write here ft per second square into 10 feet divided by 2 whole square. So this will give us the value for this Ia is equals to 31.056 select feet square. Now we can write the final kinetic energy as Tf is equals to 1 divided by 2 into 31.056 into omega square. So from here we can write this Tf as Tf is equals to 15.528 omega square. Let's calculate the initial kinetic energy, that is Vi, which is written as W into L by 2. So we can write it as 30 lb into 10 feet divided by 2. So this will give us the value for this Vi as 150 lb feet. Similarly, we can write final potential energy Vf as Vf is equals to 30 lb into 5 feet, and here we can write cosine of theta. So this is equals to 150 lb feet cosine of theta. Now by inserting these values into equation number 1, we can write equation number 1 as 0 plus 150 is equals to 15.528 omega square plus 150 cosine of theta. So from here we can write a relation for this omega square as omega square is equals to 9.66 into 1 minus cosine of theta. Let's call it equation number 2. Now let's calculate the angular acceleration and the linear acceleration corresponding to this system to relate with this omega square. So we can write summation of plus summation of ma is equals to summation of sigma of mk of a. So this yields that minus 30 sine theta dot 5 is equals to minus 7.764 alpha. This alpha is the angular acceleration minus 30 divided by 32.2, this is the mass, into alpha into 5 into 5. So from here we can write this angular acceleration alpha is equals to 4.83 sine of theta. For linear acceleration we can write this capital X is equals to minus into the mass, which is equals to 30 divided by 32.2 into 48.3, sorry, that is a 9.66, not 48, so 9.66 into 1 minus cosine of theta into 5 square brackets close sine of theta plus again the mass, which is equals to 30 divided by 32.2 square brackets open 4.83 sine theta into 5 square brackets close, and that is cosine of theta. So this is simplified as x is equals to minus 30 divided by 32.2 into, here we can write 48.3 sine theta minus 48.3 sine theta cosine of theta, and here we can write minus 224.15 sine theta cosine theta, and here square this brackets close. This can be written as x is equals to 45.0 sine of theta into 1 minus 1.5 cosine of theta is equals to 0, because in this direction there is no net acceleration. Now in case of the ladder begins to slide, at that case we can write this x equals to 0. Then we can write the relation for theta greater than 0 as 45.0 sine theta into 1 minus 1.5 cosine of theta is equals to 0. So from here we can write the angle theta as theta is equals to 48.2. This is the required answer. Thank you.